Welcome to BC Mnemonics. In this video, we're going to be taking a look at how the equatorial sundial can be used to create projections resulting in the horizontal, vertical, or analematic sundial. Now, while we are focusing on the horizontal dial to begin the demonstration, it's worth noting that, that any sundial could be created, not just limited to these three main types, from this method of projection. Because there are an infinite number of projection surfaces, not just equal to the local horizon, this dial can essentially result in an infinite number of projected sundials. As long as the dial is inclined to the latitude of use, the projection source can come from any direction and fall on any plane. But with that out of the way, let's get to the actual horizontal sundial. So a horizontal sundial results when the equatorial sundial is projected down onto a plane level to the local horizon at an angle. The projection is coming from an angle equal to the gnomon of the dial. So that's being shown in this diagram, but I will also display it with a light here. So as you can see, when the light source is coming from just above the gnomon, the circle of the equatorial ring is preserved and has its exact same dimensions on the projection as it does on the equatorial dial itself. So what this means is that the horizontal dial retains the dimensions of the equatorial dial, and in fact its gnomon, most importantly, retains the same angle. So as you can see here on the projection, the shadow down here, the gnomon assembly is reduced to a single point that is parallel to the source of the projection rather than the full extended scale. And as you can see on the diagram, this means that the horizontal dial, if its gnomon were to be extended, would pass through the equatorial dial being projected, and essentially they share a gnomon, they share an angle, and the equatorial dial is simply translated down and diagonally down at an angle equal to its equatorial band down to the local horizon until it intersects with the ground, projecting the horizontal dial. Now this can also be done on a vertical surface, as seen in the diptych, and in fact I have another diagram here showing exactly that. So in this diagram we see a horizontal and vertical dial projected by the equatorial dial. Now I can even demonstrate that here. As you can see, this exact same gnomon functions as both the gnomon of the horizontal and vertical dial, and if translated up and to the left, this equatorial plane would intersect with the vertical surface, yielding these hour lines, and if translated down and to the right, same thing would occur with the lower leaf. So that's simply a demonstration of how the equatorial dial can be used to project vertical and horizontal sundials. But let's move on to the third type, the analematic. So in this diagram, as you can see, the analematic dial, as opposed to the horizontal vertical dial, is projected straight downward at an angle that's not equal to the angle of the gnomon. Still, the projection plane is the local horizon, but that is where the similarities end. So again, as you can see here, I'll demonstrate the projection method with the light here. The shadow of the equatorial ring is not the same circle as it was with the horizontal dial. This circle is distorted and is now an oval, yielding the oval-shaped hour points of the analematic dial, rather than hour lines. Also, the gnomon will result differently from this projection method than it would from the horizontal dial, as it is not projected in a straight point, but rather the full length of the gnomon assembly is projected. And you can also see this on the diagram here, as the straight single gnomon of the original projected equatorial dial is turned into a movable gnomon that is positioned between the extremes of the winter and summer solstice on the projected analmatic dial. So what this results in is an analmatic dial with a gnomon that must be moved to correspond with the current month of use. Now that will conclude this demonstration, and I thank you for watching.